Okay, so this is 6.6, and this is a real important lesson. And how in the world did I skip 6.5? I think there's a method to my madness, so let me pause and make sure I'm doing what I want to do. Okay, so we are on 6.6, and we're doing solving equations with rational numbers. Solving equations with rational numbers, meaning we're going to solve equations where there are fractions involved. We're going to solve equations where there are fractions involved. So when quantities are both added to and multiplied times the variable, move things added first. Okay, so you've got to remember that, and we're going to apply that and deal with that, and then we're going to deal with other situations. Okay, so in this first scenario, you can see we have x plus 3/5 equals 9/10. Now, there are a couple different ways to skin the cat. And there are a couple different ways to solve equations that have numbers of fractions in them. These that we're dealing with today so far are pretty simplistic ones. So in this situation, we simply have something added to the variable. So if we wanted to isolate the variable, what would we move? Somebody raise your hand. What would we move? Christina?
0, 5.
Okay, we would move the 3/5. So how would you move the 3/5? We would add its opposite to both sides. Now, with a fraction, though, the vertical method is not the best method. We've been using the vertical method. With fractions, we want to use the horizontal method. So go ahead and use your black and write your x plus 3/5. Then take your red, and next in red, do negative 3/5. That's all the left-hand side of the equal sign. Go back to your black, do equals, do 9/10. Take your red, and do, again, negative 3/5. So we still added the opposite to both sides. We just used a different methodology. We used the horizontal method instead of the vertical method. Instead of writing the negative 3/5 underneath the left-hand side and underneath the right-hand side, we wrote it as horizontally with the left-hand side and the right-hand side. Now you might say, well, why did you do that? All right, well, first off, on the left, that's 0, right? Positive 3/5 and negative 3/5 is 0, and that's always what we're after. But notice the right-hand side, we have fractions to add. Is the methodology of solving fractions, is it vertical or is it horizontal? It's horizontal, and that's why we want to do the method this way. Because as soon as we look at 9/10 minus 3/5, our brain should say, oh, I need a common denominator, because I'm adding fractions. And so hopefully you decide the lowest common denominator is 10, and therefore I'm going to multiply the second fraction, I want that to be green, with a 2 on the bottom, right, to get our 10. And whatever we do to the bottom, we'll do the same thing to the top. Now I'll come down and show the rule step. 9 minus 6 over 10, right? The numerator of the left fraction is 9. You got a minus, 3 times 2 is 6. Over the common denominator of 10. Final answer, x equals 3/10. That wasn't too bad. Not a big deal. Not too tough. Okay. We simply applied the things that we've learned already. The only difference is we used the horizontal method when adding quantities to both sides instead of the vertical. Let's try another problem. All right, so what if we had negative 3 minus 1/4 equals 5/6? So what are we going to do first? Somebody raise your hand and tell me, what are we going to do first on this problem? Nia?
Move things out of first by adding 1/4 to the bottom of 6.
I agree. So Yep, so we're going to add 1/4 to both sides. And it's a positive 1/4 because Nia said 1/4, right? When you say 1/4, that's positive. Now, by the way, look at the methodology here. It's to your advantage to leave a little space before you write your second fraction. And I'm leaving that space just in case I need to work at getting a common denominator. And I'm going to have to, aren't I?
Yeah.
That'll just save me a step. Okay, so on the left, hopefully you agree the negative 1/4 and the positive 1/4 is 0 because they're opposite numbers. They're gone. But we still have on the left a negative 3y. But we got to figure out what it equals. Okay. So somebody raise your hand and tell me how to go about adding these fractions. Brendan, what do you want to do?
Find the common denominator.
And what do you think is the lowest common denominator?
24.
Not the lowest. It'll work. You'd have to reduce, but not the lowest. Colby?
12.
12. All right, so what are you going to do to get 12? So why don't you guys, I'm going to pause. Why don't you, well, let's finish this step. We'll do this one. I'll let you do the next one. So what do you want to do, Brendan, to the 5/6?
Put a 2 on both sides.
Okay, so you mean put a 2 on the bottom, and whatever I do to the bottom, do the same thing at the top? Okay. So we definitely want to multiply the 5/6 by 2/2. And Daniel, what do we multiply the 1/4 by?
3.
Okay, so 3 on the bottom, whatever we do to the bottom, do the same thing over top, right? Not just a 3, but 3/3, right? Okay, so now rule step. This makes the problem a little long here. That could be blue or black, doesn't matter. We can go back to black. We got a 10 on the left and a 3 on the right over our 12. So here's where I'm at right now. Let me add that numerator. Negative 3y equals 13/12. And I need to go higher here. Now, this shouldn't be a problem to finish. Shouldn't be a problem for anybody in this room to finish this problem. So I want you to go ahead and finish it. I'm going to pause the video. All right, so on 3, give me your answer out loud. Here we go. 1, 2, 3. Okay, I sense a lot of non-confidence, and I don't know why. Answer this question for me. Things multiplied times a variable are moved by. Things multiplied times a variable are moved by.
Reciprocal.
Both sides by the what?
Reciprocal.
Did you do that?
Yes.
Did you multiply the left by 1 over, oh my green there, 1 over negative 3? And did you multiply the right by 1 over negative 3? How many did that? That's what I taught you to do. All right? Do you want to do the shortcut in this case? No. You want to multiply by the reciprocal. You don't want to do the shortcut because you already have a fraction. Okay. That isolates the y on the left. I'm going to look to r bum, reduce before I multiply. Can I reduce this one? And the answer is no. If I have a negative denominator, do I leave my negative in the bottom? Yes or no? No. So I'm going to put it in the top. So I have a negative 13 in the top, and the bottom is a 36. How many got negative 13 over 36? Okay. Now some of you may have done it the more difficult way. The easiest way, we're simply going to multiply by the reciprocal. Not a problem. We know how to do that. We just end up multiplying fractions, and we're ready to roll. Okay? So that's that situation. Now the third scenario is a little bit more involved than that, because now we have 3 fractions. The multiplier of the variable is a fraction. The quantity added to the variable is a fraction. And then on the other side is a fraction. But the procedures are the same. Things added to the variable are moved by adding their opposite to both sides. Things multiplied times the variable, you move by multiplying both sides by the reciprocal. All right, see if you can do number 3. I'm going to pause the video. So depending upon which route you took, work should look something similar to this. Your homework work should look like this. So I've got some reducing here at the end. 2 and a 5. 2 and a 2. So the 2's can go. Be careful with these 5's. You still have a negative 1, right? Be careful there. So it looks like with our n isolated, I have a -2 numerator and a 3 denominator. -2 thirds. How many had that correct? Okay. And again, if you didn't, you got to look along the way and find out, where did I make my mistake? Where was my issue? Was it, sometimes it's in 7 negatives and 2 positives, and some of you got a +5 somehow. Should have been a -5. More negatives and positives. 2 of those positives wipe out 2 of those negatives, leaving you 5 negatives left, right? And away you go. Some might say, Mr. Scarfy, why didn't you reduce right here before moving the 3/4? Because I know that in any multiplication step, I'm going to reduce before I multiply, and I'll just do it all in one time. You could, if you wanted to, and do an extra step, but I know on the multiplication step, I'm going to R-bum, right? So if there's reducing, I'll just catch it right there. All right, let's do a couple more problems. All right, so number 4, similar type problem, a couple pitfalls. See what you can do with that. I'm going to pause the video. All right, on 3, give me your answer out loud, nice and loud. 1, 2, 3.
-n equals 11.
Okay, I heard some wrong answers. How many got n equals -11/8? You would be the correct ones. All the rest of you would not have finished the problem correctly and gotten the correct answer. We've done this before. You never solve for the variable as negative. You always solve for the variable as positive. This negative sign here goes to there, goes to there, and goes to there. And therefore, you have a -1/3. We've talked about that before, and we've done that before. Therefore, we're going to multiply both sides by 3 over -1. And that is going to end up giving us, as we reduce, a -11/8. -11/8. Any questions on that one? Question? Okay.
How'd you get the 8 for the denominator?
The 24 is a 3 times 8, and the 3 is divided out, leaving an 8 in the bottom.
Okay.
Because the 24 was from adding the numerators, putting them over the common denominator. So again, I reduced before multiplying, so I didn't get 33. I don't want -33 over 24 because that reduces. I want -11/8. R-bum, reduce before you multiply. Okay, one more. Let's look at our last example here. So we're going to look at this and say, I have no earthly idea what to do, right? And honestly, there could be more mixed numbers. We could also have a third mixed number if we wanted to, on the same side as the variable. Not a big deal. So somebody raise your hand. What do you think we're going to do to solve this thing? What's going to be the concept? Ashley?
Make the mixed numbers improper fractions.
Yeah, let's just make all improper fractions, and then, so just do that. What I want you to do is make the left side an improper fraction, make the right side an improper fraction, then just stop. So I want to make sure you know how to finish it off correctly. Emily, you there already? You got your improper fractions? So Julia, what's your left fraction? Great, so that is correct, right? That's a -11/4. Negative the quantity 2 times 4 plus 3 gives you -11/4. And Raph, what's your right-hand side?
37/8.
37/8. Agreed. Now in a problem like this, don't say anything out loud. What's going to be the next step? What is the next step? Chloe?
Multiplying both sides by the reciprocal.
So tell me what to multiply both sides by.
4 over -11.
Yeah, this one, there's nothing to move that's added to the variable. Now, sometimes there will be. and you'll have the mixed number that you made an improper fraction, and you'll move it. But this one, we're already ready to move the negative 11 over 4 by multiplying both sides by its reciprocal, right? That leaves the n isolated on the left. Hopefully you see you can reduce, right? Again, our negative is going to go in the top. So I have negative 37 over 22. Am I finished?
No.
I'm not?
Yes.
I am?
No, it's wait, there's two mixed
I'm not. So our final answer has to be a
numbers.
mixed number because there were two mixed numbers to begin with. Okay, so let's finish it off. 22 goes into negative 37. That's a negative 1. And what do we have? 15, 20 seconds left. And that does not reduce, though sometimes it might. But a 15 is a 3 times 5, and a 22, 2 times 11. So that's our final answer, negative 1 and 15, 20 seconds. Does that make sense? If there would have been another mixed number, guys, here in between, no problem. Turn it also to a fraction. And then the problem will look similar, well, actually, similar to like this problem is, right? Fraction with the variable, another fraction you got to move by adding its opposite, and another fraction on the other side. So all we're doing is trying to use things that we've already learned now to take the next step. So now we have equations with fractions. One way of solving them is this method. Simply deal with the fractions. There's actually a method that will allow you to get rid of all the fractions and solve it that way. We'll save that for a later situation when we get a little bit more complex. But these aren't tough. They're not that hard. You just need to be careful. You do have adding of fractions always, so you got to make sure you get common denominators. Add the numerators over the common denominator, and then you're going to have oftentimes that multiplication step. And don't forget to R-bum, or you will be one. All right? Don't be a bum. All right, you got the rest of the time. Let's work on some homework. Quiz tomorrow.